So this is problem number 11. Again, we are in module 2. Shown in the figure, 3.20 is a region in the xy plane where the bivariate PD of x comma y is equal to c. What value must c have? Evaluate xy 1 comma 1. Find the PD of f of xx and f of yy are xy independent. So first is we need to find the value of c. Now one method he has given here, but the better, easier method would be, we know the area of this triangle. What is the area of this triangle? Can somebody tell me? What is the base of this? What is the height of this? Can somebody write in the chat what is the base and height and what is the area of this triangle? Yes. How much? Okay, what is how much is the base? Base is 4, height is, how much is height? Height is also 4, right? So what is the area? Half into base into height. Okay, 8. So therefore, because the area of this is 8, okay, when we talk about the f of xy, right? Now the area under the total curve should be equal to 1. Okay, the what you call total area should be equal to 1, but now this is 8. Therefore, if you multiply that 8 by c, then the value what we get should be equal to 1. Okay, so 8c is equal to 1. You can write area of this is 8. Therefore, 8c is equal to 1. Therefore, c is equal to 1 by 8, and that will be the value of f of x. Y, that is the value of c. Okay, 8c is equal to 1 and c is equal to 1 by 8. Area of triangle is 8. Therefore, 8c is equal to 1. Therefore, c is equal to 1 by 8. What you can write for this also. This is another way of solving this. What he has done here is he has taken that the value of x is varying from -2 to 2. X is varying from -2 to 2, but y is equal to x itself. Y is equal to x itself. So for that he is taking value of y is varying, or he is taking value of y is varying from x is varying from -2 to +2. This is for x, and this is for y. Y is equal to x to y equal to 2. Okay, that is what he is trying to write that and trying to integrate that, and you will get 8c for that, and that is equal to 1, and that is c is equal to 1 by 8. Better than that is always area of this is 8, and because the area under the curve should be equal to 1, 8c should be equal to 1. Therefore, c is equal to 1 by 8. Even that you can write. Having written that, now what you can write is f of xy 1 comma 1. That will be c is 1 by 8. The 1 comma 1 is -2 to 1, -2 to 1 for the x limits. For the y limits, it is from x to 1, similar to x to 2. So if you try to do this integration, you will get 9 by 6. Okay, you will get 9 by 6. For this, you can integrate the y here, y limits 1 and x, and that will turn out to be upper limit minus lower limit. That will give me 1 minus x, right? That will give me 1 minus x, and that 1 minus x dx is what we will have. That we need to integrate and then solve it. At the end, you'll get 9 by 6. Then find the value of f of fxx and fyy. Fxx is equal to 1 by 8. Again, integral only x to 2 dy, x to 2 dy, c dy, this should be. C is 1 by 8, and if you try to solve this, you will get it as 1 by 8 2 minus x within the range -2 to +2. Similarly, fyy is between -2 to y dx, the value of c is 1 by 8, and that will give 1 by 8 y plus 2, -2 less than y less than 2. Now, if you multiply both this, you are not going to get c. Therefore, fxx into fyy is not equal to f of xy x comma y. Therefore, xy are not independent. So what we are trying to do over here is only that, we have here the cumulative distribution function in the problem number 14. What is given is the cumulative distribution function, and to find the value of c, we just need to substitute the upper limits only. So f of xy 4 comma 2 is equal to 4. C 4 plus 1 square, 2 plus 1 square is equal to, this is 25 and this is 9, and therefore 225. So C is equal to 1 by 225. So please remember that this is the CDF, not the PDF. Whereas PDF has to be integrated to get the CDF, where here the CDF is directly given. Therefore, we just need to substitute the upper limit 4 and 2. Next, we need to find the bivariate, PDF function, that is small f of xy x comma y, and for that we need to differentiate this equation by substituting the value of x with respect to dou squared by dou x dou y. Now this is partial derivative. Please remember that it is partial derivative. Once we differentiate with respect to x, another time we differentiate it with respect to y. When we differentiate it with respect to y, then this total term is constant. When we differentiate this with respect to x, then this will be constant. This as well as 1 by 225. Okay, so it will be, if you just differentiate it with respect to y, then we will get this term multiplied by 2 into y plus 1. If you differentiate it with respect to x, once more the overall value, then we'll get 1 by 225 into 2 into x plus 1 into 2 into y plus 1. So 2 into 2 will become 4, 4 by 225 into x plus 1 into y plus 1. Okay, this will be the value of dou square by dou x dou y. Then fxx will be the value of, this is the, remember that this is the CDF corresponding to dx, and for that we need to substitute f of xy x comma infinity within that. And when we talk about infinity, it is just only the upper limit we need to consider, and that is 2. So if you substitute 2 in place of y over here, then we'll get the CDF corresponding to the only x variable. So for that we'll get 9 by 225. If you substitute 2 over here, right, 2 plus 1 square will give us 9. So 9 into 1 by 225 will be 9 by 225 into x plus 1 whole square. Similarly, fyy will be f of xy infinity comma y. Okay, here x is infinity. Infinity just means, again, its upper limit. Its upper limit is 4, and that is what we need to substitute. Don't substitute infinity and get the value there, but we need to substitute the upper limit 4 into the x, and we should get that 4 plus 1 square will give 25. 25 into c will be 25 by 225 into y plus 1 whole square. Now this is within the range -1 y less than 2, because it's a function of small y, right? -1 less than y less than 2. Then evaluate the value of the probability of x less than 2 intersection y less than 1. That is, upper limit here is 2 and 1 over here. So that means, it just means f of xy 2 comma 1, and you need to substitute that value over here. C is 1 by 225. The value of x is 2 plus 1 whole square, because here it is 2. 2 plus 1 whole square will give us the value 9, and 1 is the value of y here. 1 plus 1 whole square will be 2 square. So 9 into 4 by 225, and that will give us the value 4 by 25. Are the what you call variables independent at all? Then we need to check that. If you just see the f of xy is equal to this, and f of yy is equal to this, if you multiply both of them, will you get back this with c is equal to 1 by 225? And that's really true. And therefore, we have here x and y as independent of each other. So problem number 18, the mean and the variance of the random variable x are -2 and 3, and the mean and variance of y are 3 and 5. The correlation coefficient, this is the rho xy is equal to 0.7. What are the covariance xy and correlation E of xy? So this is covariance of xy is equal to rho xy into sigma x into sigma y. This is rho and this is sigma. Okay, so this value is given to us 0.7. The sigma x and sigma y are the standard deviation, rather, right? They are the standard deviation, which is root of the variance, root of the variance. So this is root 3. Variance is given as 3 for x. So this is root 3. This is root 5 because variance of y is given as 5. So root 3 into root 5 into 0.7. You can write it like this also, root of 3 into 5. Or separately, you can write root 3 into root 5 also. You'll get 2.711. Then you have the correlation. Correlations is the covariance plus the multiplication of the two means. Okay, so 2.711 plus the what you call mean of x is -2, mean of y is +3. So we are multiplying that. We are getting -6, and this is plus 2.711. So overall, we'll get minus 3.2889. Okay. So this is, I don't think there might be any difficulty in this. Okay. So we'll go forward. The mean and variance of the random variable x are -2 and 3 again. And the mean and the variance of y are 3 and 5. Same values are given. Correlation is given here as -8.7 in place of the correlation coefficient. We are given the correlation here. What are the covariance of xy and the correlation coefficient, rho xy. So covariance xy in terms of the correlation coefficient is written like this, but in terms of the correlation and the mean can be written like this, E of xy minus mu x mu y. So E of xy is given to us as -8.7, mu x mu y is -2 into 3, and minus of minus will become plus, so therefore it will be 6. So on the whole, this will be -2.7. So the correlation, coefficient will be covariance of xy divided by the, the standard deviation of both x and y. That is the root of the, variances. So -2.7 divided by root 3 into root 5. So in the denominator, we should have root 3 and root 5, and both here joined and together written. You can write it separately also and write it, and that will give us the value which is -0.6971. What you call, so 22 is x is random variable with mean value 4, and the standard deviation given here. Variance is not given, standard deviation is given. So the variance will be squared of this, that is 25. Y is the random variable, again mean is given 6, and the standard deviation is given as 7. Correlation coefficient is 0.7. U is equal to 3x plus 2y. What are the variances of u? Covariance of ux and covariance of uy. So covariance of xy is what we'll try to find first, so that we can use that same thing in the other ones. Okay, so covariance of xy is sigma xy, correlation coefficient is given as 0.7, and sigma x and rho xy and sigma x sigma y, that is 0.7 plus 0.7 multiplied by 5 multiplied by 7, that will give us 24.5. Then the sigma u square is equal to E of u minus mu u square, and we can substitute within that and try to get the value of the variance of u. This is the variance of u. So variance of u is E of u minus mu u whole square, and u itself is nothing but 3x plus 2y. We can just write here 3x plus 2y. And the mean of this also one can take, right? And that we can try to expand, right? So the mean of that also can be considered, or you can just try to write this as the expansion over there, which is something like this, which is e of 9 of x minus mu x square plus 12 of 12 into x minus mu x, y minus mu y plus 4 into y minus mu y whole square. Okay, so we are just trying to substitute the value of 3x and 2y over here. U is a combination of 3x and 2y. So corresponding to this 3x, it will become 9 of sigma x square. And corresponding to this 2y, this will become 4 into the y minus mu y whole square, right? And corresponding to the combination of both, that is 2 into 3 into 2, that will give us the value 12 into x minus mu x into y minus mu y. Okay, so that's what he has just written over here, and that will be 9 you can take out, and the expectation of this itself, this is nothing but the expectation of x minus mu x whole square will give us the sigma x square, and expectation of this quantity is the covariance of xy, and expectation of this is equal to the sigma y square with the constant coefficients 9, 12, and 4 as it is. So you just need to substitute the value of 5 over here and the value which is found here 24.5 here and the value over here as 7 square, and that will get it as 750. Then next is the covariance of ux. Covariance of ux is nothing but expectation of u minus mu u into x minus mu x. Now this is nothing but we need to write both the quantities together. This is nothing but 3 into x minus mu x plus 2 into y minus mu y, right? 3 into x minus mu x plus 2 into y minus mu y, because we have u is equal to this. So the value of the expectation of these two quantities will be what you call mean of this expectation of these two quantities would be just 3 into the corresponding value over there and the corresponding value over here, and this has to be multiplied over here. So if you expand that, then again we will have this as the sigma x and this as the sigma x. So therefore we will have 3 sigma x square, and this is 2 sigma y, and that 2 sigma y is to be multiplied by the sigma x, and that will give you root of so to say that value, and this multiplied by this will give you the covariance corresponding to that, and that will give you the value which is you need to substitute over here 3 into 5 square plus 2 into the covariance which is found here as 24.5, and that will give us 124. Similarly, the covariance of u and y, so wherein we need to write one value as u and another value as y, and again you for u he's trying to expand it like this, 3 into x minus mu x plus 2 into y minus mu y, and this is as it is y minus mu y, and that will give you 3 into this multiplied by this will give you, this multiplied by this will give you the value covariance, and this multiplied by this multiplied by this will give you 2 into the sigma y square, and just you need to substitute again 24.5 here, and sigma y square is 7 square over here, and we'll get 171.5. So which is 25. 25 is x and y are correlated random variables with a correlation coefficient of rho equal to 0.8, mu x equal to 20, variance x is equal to 70, mu y is equal to 15, variance of y is equal to 100. The random variables u and y are obtained using u is equal to x plus cy plus v is equal to x minus cy. So two different values u and v are given over here. What values can C have if u, v are uncorrelated? the most important thing here is uncorrelated. Okay, so for this we need to just find that the covariance of u and v should be equal to 0 for them to be uncorrelated. Covariance of u and v should be equal to 0. So covariance of u v is e of u minus mu u v minus mu v, and that is again you can just try to write it corresponding to that. The expansion for this uv, we can just for each one of the u is nothing but x plus cy, and for v it is x minus cy. So therefore you can try to write that for this combination it is x minus mu x plus c into y minus mu y. For this combination it is x minus mu x minus c into y minus mu y, because we have it like this. Okay, for each one of this we need to write it like that. So if u is this, what will be u minus mu u? Okay, if v is this, what might be v minus mu u? And that will be the value corresponding to this as well as this. Okay, so you need to write that and multiply that, and you will get sigma x square minus c square x square, and this value should be equal to 1. For this to be equal to 1, we should have c is equal to sigma x square by sigma y. C square is equal to sigma x square by sigma y square, and c is equal to sigma x by sigma y, and that will give us the quantity which is to be substituted. But because root is there, it can be plus or minus, c can be plus or minus, and the value given for sigma x and sigma y are the root of the so to say 70 and root of the 100, and therefore it becomes root of 70 by 100, and that will be plus or minus 0.8367.